Yes, it is on various computers. Various computers with same characteristics, same hardware, infrastructure type, same operating system, same applications. They are the same, or heterogeneous computers. They are different computers, different hardware, different operating systems, and so on, distributed globally or locally. Computers, those homogeneous or heterogeneous computers can be distributed locally or globally according to the characteristics of localization. Localization for equality, distributed systems have different subsets such as grids, clusters, clouds, etc. So these are technologies enabling cloud computing. Cloud computing developed from these two clouds, from supercomputers, grid clusters, web 2.0, two clouds. So their technologies enabled the cloud computing. These are technologies which enable the cloud computing. So clusters. Characteristics of clusters are that the computers being linked to each other are normally distributed locally. So those computers are distributed locally and have the same kinds of hardware and operating system. So same kinds of computers are used and they are located at the same location, and they are same kinds of computing with same hardware type, same hardware and operating system. Therefore, cluster workstations are connected together and can possibly be used as a supercomputer. So cluster computers are connected locally, and they work together to achieve the same goal, and they operate as a supercomputer. It is a way of using many computers to perform a big task. A big task. This is the evolution. A cluster is a collection of parallel distributed computers which are interconnected among themselves using high-speed network. They work together in the execution of compute intensive and data intensive tasks that would be not feasible to execute on a single machine. So that is the main purpose of using many computers when there is a big task like weather forecasting. So computers detect for controlling tectonic motion activities and so on, weather forecasting, prediction or artificial intelligence activities requires huge computational tasks. In that case, we need these kinds of technologies to achieve such kinds of tasks. Clusters are used mainly for high availability, load balancing, and for compute purpose. They are used for high availability purpose as they maintain redundant nodes which are used to provide service when system component fails. High availability means what? We use many computers which have redundant, the same, we have many copies of the same task. Why do we need many copies of the same task over different computers? It is for backup purpose. When a task needs high availability, for example, mobile money in MTN, mobile money service in MTN, it needs high availability. That is why that application is not hosted on a single machine, but it is distributed in many computers so that if one fails, others provide the same service. So that is the one of the reasons we need such kind of clusters, many computers which are working together to achieve the same goal. So we can have the same application in 10 computers, so that one fail, another provide the service. One fail, another provide the service. Another is load balancing. Another is load balancing means what? We have a huge task. We have a very, very big task which cannot be performed by a single computer. If we have a big task which cannot be performed by a single computer, we can use load balancing. Load balancing, I told you that it is a big task which is divided into subtasks, and those subtasks are distributed into many computers. So in that case, the speed, the speed or the result is got quickly as there is a load balancing, there is distribution of tasks into many computers. Load balancing and for compute purpose. They are used for high availability purpose as they maintain redundancy nodes which are used to provide service when system component fails. So they continue to provide services when even when the one computer or the system fails. So the performance of the system is improved here because even if one node fails, there is another standby node which will carry the task and eliminate a single point of failure without any hindrance. So you see, we have the performance is high because we don't have a total failure of the system, because if one system fails, another one take over. When multiple computers are linked together in a cluster, they share communication workload as a single virtual computer. From the user's viewpoint, there are multiple machines, but they function as a single virtual machine. There are many physical machines from users' point of view, but logically they operate as a single machine, a single logical machine. The user's requests are received and distributed among all the standalone computers to form a cluster. This results in balanced manipulation work among the different machines, improving the performance of the cluster system. Often clusters are used mainly for computational purpose and handling input-output based activities. Through supercomputers. Supercomputers is a very big machine which performs a huge task. So supercomputers can be easily compared to clusters. Supercomputers can be easily compared to clusters because it follows the same concept, except that the fact that it is matched into one box already and is not locally interconnected with another machine. So, supercomputer is a one big machine which having many processors inside. And those processors works like standalone machines. And it receives a big task and it distributes that the portions of that task into different processors to achieve the same functionality as clusters. So it don't need to be locally interconnected with other machine. IBM is constructing those machines consisting with a lot of processors that are matched into one machine with high performance capabilities. The only disadvantage is that they are usually expensive and have the necessity of a huge amount of energy. So they are very expensive. The disadvantage, they are very expensive and they consume a lot of electricity, a lot of energy. So grid computing, apart from clusters and supercomputers, we have grid computing. When finishing grid computing, it is necessary to differ it. When defining grid computing, it is necessary to differ it from clusters. While clusters are distributed locally and obliged to use the same hardware and operating system, grid involves heterogeneous computers that are connected to each other and distributed globally. First of all, they don't need to be located at the same physical place, the same area network. Secondly, computers are not homogeneous like in clusters. So we use in these types of computing, we use heterogeneous computers with different hardware and different operating system can make a grid computing. And they are distributed globally. You can locate any computer anywhere. You don't need to interconnect them physically at the same location. You understand the difference between grid computing and cluster computing. So computers that are connected to each other, and grids involves heterogeneous computers that are connected to each other and distributed globally. The operating system and hardware that runs on those computer machines can also be different from each other. So it is not necessary to use the same hardware and the same software. It is not necessary to interconnect these computers at the same location, physical location. Grid computing can be defined as a network of homogeneous or heterogeneous computers working together over a long distance to perform a task that would rather be difficult for a small machine. A task which would be difficult for a small machine can be performed by a grid computer using a grid computing technologies. So you can see that we are approaching cloud. We are approaching cloud computing because grid is it is a set of computers, heterogeneous computers located anywhere, which works together to achieve a goal which would be difficult to achieve by using a single machine. Grid computing is a distributed structure of a large number of computers connected together to solve a complicated problem. In grid computing, servers and computers run independently and are loosely connected by the internet. Computers may connect directly or through the scheduling system. In other words, grid computing involves a large number of computers which are connected parallel and makes a computer cluster. Grid computing is used in various types of applications such as mathematical, scientific, and dedication of tasks via various computing resources. Grid computing is a processor architecture that integrates computer resources from various domains to achieve a primary goal. The computers on a network will work together in a grid computing on project that's acting as a supercomputer. So we have explained grid computing enough. Now, apart from grid computing, we have cloud computing. Together with virtualization, cloud can be defined as computers that are networked anywhere in the world with the availability of paying for the used clouds in a pay per use way. Grid, grid, which is the same most of the time, which is an organization which use grid for their private their private tasks. It is an industry, it is a bank, it is whatever, and so. But for cloud computing, it is the same as a grid, but provides service to the community, to the public in a business way, because users or customers pay as they consume the service, meaning that just the resource that are being used will be paid for. That is the main difference between grids and cloud. Cloud services are available over the internet. Customers will consume and pay for that kind of service. In the following, cloud will be introduced. Cloud computing is defined as all on the demand facility of compute power, database storage, on demand facility, on demand access of computer power, storage, database storage, applications, and other IT resources through the internet. It provides a solution for IT infrastructure at a low price. It is in simple words, cloud computing means storing and accessing data via the internet instead of computers hardware, users computers hardware. So you store your data, your application, your whatever over the internet instead of storing them into your computer. And you pay. Cloud computing refers to both application platform and software delivered as a service over the internet. You can define it like this. It refers to application, platform, software, infrastructure delivered as a service over the internet, and the hardware and the system software in the data centers that provide those services. Cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources, central network servers, storage, applications, and service that can be rapidly provisioned and released within minimal management effort or service. So you understand that when you say that cloud computing is cheap, it is because you don't need, first of all, when you buy your infrastructure and store those infrastructure locally, you need also technician, okay, to maintain those infrastructures, to maintain those softwares, to maintain whatever, to manage those local resources. But when you use cloud infrastructures, when you use cloud storage, when you use cloud hardware, you don't need to hire, you don't need to hire those technicians, you don't need to hire database administrators, you don't need to hire maintenance technicians, because all those kinds as cloud service providers. So now, when it comes to mobile cloud computing, as you have seen, mobile cloud computing, those services now can be accessible via mobile devices. Those cloud computing, when they are being accessible via mobile devices, now we call mobile cloud computing. The mobile cloud is internet-based data application and related services. When the cloud services are accessible through mobile devices such as smartphone, tablet, and laptop, so in that case, we call it mobile cloud computing. Thank you so much. Any question? Any question? Any question? So I suppose that there is no question. There is no question. Then thank you for attending. So you need to start working on your assignments. And then based on the deadline provided, you need to work on your assignments and don't miss any assignment, don't miss any deadline. Thank you for attending. See you next week on Wednesday.